Section 9.4, Distributed Session Management with Redis. In the previous chapters, I often highlighted how cloud-native applications should be stateless. We scale them in and out, and if they weren't stateless, we would lose the state every time an instance is shut down. Some state needs to be saved, or the applications would probably be useless. For example, catalog service and order service are stateless, but they rely on a stateful service, the PostgreSQL database, to permanently store the data about books and orders. Even if the applications are shut down, the data will survive and be available to all the application instances. Edge service is not dealing with any business entities it needs to store, but it still needs a stateful service, Redis, to store the state related to the request rate limiter filter. When Edge service is replicated, it's important to keep track of how many requests are left before exceeding the threshold. Using Redis, the rate limiter functionality is guaranteed consistently and safely. Furthermore, in Chapter 11 you'll expand Edge service to add authentication and authorization. Since it's the entry point to the Polar Bookshop system, it makes sense to authenticate the user there. Data about the authenticated session will have to be saved outside the application for the same reason as the rate limiter information is. If it wasn't, the user might have to authenticate themselves every time a request hits a different Edge service instance. The general idea is to keep the application stateless and use data services for storing the state. As you learned in Chapter 5, data services need to guarantee high availability, replication, and durability. In your local environment, you can ignore that aspect, but in production, you'll rely on the data services offered by cloud providers, both for PostgreSQL and Redis. The following section will cover how you can work with Spring Session Data Redis to establish distributed session management. Section 9.4.1, Handling Sessions with Spring Session Data Redis. Spring provides session management features with the Spring Session project. By default, session data is stored in memory, but that's not feasible in a cloud-native application. You want to keep it in an external service so that the data survives the application shutdown. Another fundamental reason for using a distributed session store is that you usually have multiple instances of a given application. You'll want them to access the same session data to provide a seamless experience to the user. Redis is a popular option for session management, and it's supported by Spring Session Data Redis. Furthermore, you have already set it up for the rate limiters. You can add it to Edge service with minimal configuration. First, you need to add a new dependency on Spring Session Data Redis to the build.gradle file for the Edge service project. You can also add the test containers library so you can use a lightweight Redis container when writing integration tests. Remember to refresh and re-import the Gradle dependencies after the new addition.
Listing 9.16, Adding dependency for Spring Session and test containers.
Next, you need to instruct Spring Boot to use Redis for session management, spring.session.storeType, and define a unique namespace to prefix all session data coming from Edge service, spring.session.redis.namespace. You can also define a timeout for the session, spring.session.timeout. If you don't specify a timeout, the default is 30 minutes. Configure Spring Session in the application.yml file as follows.
Listing 9.17, Configuring Spring Session to store data in Redis.
Managing web sessions in a gateway requires some additional care to ensure you save the right state at the right time. In this example, we want the session to be saved in Redis before forwarding a request downstream. How can we do that? If you were thinking about whether there's a gateway filter for it, you would be right. In the application.yml file for the Edge service project, add Save Session as a default filter to instruct Spring Cloud Gateway to always save the web session before forwarding requests downstream.
Listing 9.18, Configuring the gateway to save the session data.
That's a critical point when Spring Session is combined with Spring Security. Chapters 11 and 12 will cover more details about session management. For now, let's set up an integration test to verify the Spring context in Edge service loads correctly, including the integration with Redis. The approach we'll use is similar to the one we used to define PostgreSQL test containers in the previous chapter. Let's extend the existing Edge Service Application Test class generated by Spring Initializer and configure a Redis test container. For this example, it's enough to verify that the Spring context loads correctly when Redis is used for storing web session-related data.
Listing 9.19. Using a Redis container to test the Spring context loading.
Finally, run the integration tests as follows.
See this code.
Should you want to disable the session management through Redis in some of your tests, you can do so by setting the spring.session.storeType property to none in a specific test class using the test property source annotation, or in a property file if you want to make it apply to all test classes. Polar Labs. Feel free to apply what you learned in the previous chapters and prepare the Edge service application for deployment. 1. Add Spring Cloud Config Client to Edge service to make it fetch configuration data from config service. 2. Configure the cloud-native build packs integration, containerize the application, and define the commit stage of the deployment pipeline, as you learned in chapters 3 and 6. 3. Write the deployment and service manifests for deploying Edge service to a Kubernetes cluster. 4. Configure Tilt to automate the Edge service deployment to your local Kubernetes cluster, initialized with Minikube. You can refer to the Chapter 09/09 end folder in the code repository accompanying the book to check the final result. See this link. You can also deploy the backing services from the manifests available in the Chapter 09/09 end/polar deployment/Kubernetes/platform/development folder with kubectl apply F services.